So in order to get from the standard form of a quadratic expression to the vertex form, we need to be able to somehow go from something with two variable terms, an x squared term and an x term, to something where we have x plus a number squared. And in order to do that, we need to be able to manipulate our expressions so that they contain a perfect square trinomial. And in particular, we want to do that by manipulating just constants because we don't want to have extra x terms floating around. So the procedure we're going to use is called completing the square. The claim is if we have x squared plus a number times x, there is a third number that we can add on there that'll give us a perfect square trinomial. And I really want to encourage you to think about this geometrically because there is a formula that you can memorize, but thinking about it geometrically is substantially less error prone. So let's think of multiplication as representing the area of a rectangle, as we did when we first multiplied polynomials. And we're going to think of our constant then as a missing piece of a square. So here I have x squared plus 6x, and I want to figure out what constant I can fill in to get a perfect square. And here's how I'm going to do that. All right, so I've drawn a square here. It's a square, its length and width are the same. And I'm going to think of my x squared as being this bigger square. So this length and this length are both x. Now, these two smaller rectangles here, this one and this one, they have the same area and they have x on one side of them. So what I'm going to do is I'm going to split my 6x evenly between the rectangles. So I'm going to say, well, 6 divided by 2 is 3. In other words, 3x plus another 3x is 6x. And I chose 3 and 3 specifically because they're the same. So I'm going to put 3x over here and another 3x over here, which means that this rectangle is 3 on this side and x on the left. This rectangle is also 3 on this side, which means that the extra little square in the bottom right corner down here is 3 on each side. So its area is 3 times 3 equals 9. The little missing piece that I need to add in order to fill in the square is 9. And the sides of my square are each x plus 3. So my square is x plus 3 by x plus 3. And when I multiply that out, I get x squared plus 6x plus 9. And I can check that that works. Right? X plus 3 times another x plus 3 gives me an x squared plus 3x plus another 3x plus 9. And when I combine those like terms, I really do have x squared plus 6x plus 9. So in finding this constant, I'm finding the missing piece of my big square. Now, that one worked out pretty easily because when I took that 6x and split it in two, 6 was an even number, so I ended up with integers all around. Sometimes when we do this, fractions show up. So here again, I have x squared minus 5x plus something is going to give me my square. So I'll have an x squared in the larger square in the top left, which means that this side has length x, and this side also has length x. Next, I'm going to look at my two smaller rectangles here. They're x on one side, and I want to divide negative 5x evenly between them. Now this is negative. We're going to be pretending that it makes sense for a rectangle to have a negative side length. But when we take negative 5 divided by 2, we get negative 5/2. So each of our little rectangles is going to get a negative 5/2 x. And so each of these segments is going to have length negative 5/2, which means that the little square in the bottom right corner, our missing piece, is going to have area negative 5/2 times another negative 5/2 is 25/4. So our missing piece is 25/4, and what we're squaring is x plus negative 5/2. Or we could just write x minus 5/2 squared. So if it happens that that middle term, that x term, isn't an even integer, we'll end up with fractions. Sometimes it's going to turn out that that middle term is itself a fraction. And that's going to happen especially because notice that in this game, we always have 1x squared. We'll often get fractions turning up in the middle term when we try to arrange that. But that's fine. So we'll start off, we have x squared plus 5/3 x, and we want to complete the square. So we'll start off with an x squared in the top left. Its side lengths are x and x. Now our two little rectangles, here and here, we want to split 5/3 x evenly between them. And so we'll say 5/3 divided by 2. And so that's 5/3 times 1/2 is 5/6. So each of our little rectangles is going to contain 5/6 x. So this remaining side length is going to be 5/6. And the area of our missing piece, the area of our smaller square down here, is going to have to be 5/6 times 5/6 is 25/36. Our missing piece is 25/36, and we get that by squaring x plus 5/6. So that's how we complete the square. To complete the square, we need to figure out what that little missing piece is. And then the way that we handle that little missing piece is going to depend on what it is we're trying to do with our completed square.